one of the big things added as of AFSDK 2.5 is the ability to go directly against PI tags on a PI archive server. This can be useful if we're doing kind of legacy compatibility type things, or for tags that aren't mapped in the asset framework. So there are two big things on my mind that we want to look at here as far as dealing with PI tags. One has to do with the PI tags themselves, just looking at really how they are and how to find them. And then the second interesting part will be to make an event pipe, where imagine we're a calculation engine or a notification engine. We don't want to rely on our polling rate not to miss important events. What we want to do is periodically ask the server, the PI server, to tell us updates. What's new since I last asked? And the PI server will empty out the bucket of all the new stuff that arrived with our name on it since we last asked. So if we, in step 1, find a list of PI tags, step 2, with this event pipe thing, we can sign up for updates on those PI tags that we found, and then periodically ask the PI server, hey, do I have new events that have come in for me on any of these PI tags that I want updates for? If you're interested, clients like ProcessBook and PyAce and PyNotifications use this same event pipe mechanism from legacy things like the Pi SDK. Here we'll do it in the AFSDK. And because this is a rather simplistic interface that we'll need, we'll just do this as a console application. So I'm going to add a new console application for a PI tag adventure. Alright. Now, of course, we'll need a reference to the AFSDK in our project. By now, this should be easy enough to do, especially since the AFSDK .NET 4 version should be in our recently used items. And we're used to adding a big long list of using statements at the top, but here, since we're really only dealing with PI tags, we're going to start off just by adding the OSIsoft.af.pi namespace. Cool. Okay. So when someone fires up our app here, step 1 will be, well, I guess step 0 will be connect to a PI server. And then step 1 will be prompt the user to search for some tags. Later, we'll get to building the event pipe and scraping new events periodically. So in the AFSDK, the root of the world begins with the Pi systems object. If we pull up the entry in the trusty AFSDK reference guide, we can see the object hierarchy in the Pi namespace starts with something very similar, which is the Pi servers root object that then contains something very promising looking called a Pi server. Of course, in that Pi server, we've got all sorts of Pi points that we will be searching for. All right, so let's start out with one of those Pi systems objects, or Pi servers objects. Within that server, we could do things like get the default Pi server, or just pick out Pi server that we want by name. My server that I want is called Loot. Perfect. So now that we've got a Pi server picked out, we have the option to connect to it explicitly with the server.connect method. You know, if we want to offer some packaged up network credentials, or if we want to allow for an interactive logon, something like that. Otherwise, this will be implicit, so we're good. Doing it explicitly, we might be able to trap for any connection errors or authentication errors, so that could be a good thing to do it explicitly if we really want to. Otherwise, it could just be a part of our general error handling scheme. Okay, so we know our server, we know what server we're going to be searching within to find some tags. So what I want to do is prompt my user for, hey, what tags are you looking for? Now in Pi, there's a name masking syntax for something like sin star will return all the Pi tags that start with sin and end with anything. So let's get that mask. Which is the response to our question. What tag mask do we want to use? Okay, once we have a tag mask, in that PyPoint object that I remember seeing in the hierarchy, it is mentioned that there is a PyPoint.find method here. It's exactly what we want. So PyPoint.find PyPoints. There are several overloads, as we can kind of see here. Things involving PyPoint queries and searching by name. And if you look in the docs, in fact, in the PyPoint class, in the list of methods that are here, we get a quick description of what all capabilities are offered. There's this PyPoint query object where if we're trying to query for example, all points that have been whose configuration has been changed since the last time we looked, or points in a given point source or with a certain instrument tag, something like that, in the point configuration, we might want to use a stack of these PyPoint queries. Otherwise, what we're trying to do here is someone's told us a name mask. Well, it's just one name mask, but that's okay. It's still, we're searching by name. So we're going to use the overload that involves just kind of purely searching by name. Not the only way to do this, but probably the easiest. So here, for that overload that involves searching by just by name, the first argument is the server. Second argument is a list of PyTag names we want to find. Now, in our case, the user is probably going to put in something like sin star, or at least they have the ability to do that, and that's fine. That'll work here. We can just make ourselves a new string list with our mask in it, and optionally load in any point attributes that we want to. Okay, now, the purpose of our application here is just to get data from the PyPoint. We don't really want to read the configuration of it, so we get to ignore this. But if you're writing an app where you need to actually read the configuration of certain PyPoints, like maybe you're writing a custom Pi interface or something like that, well, in that case, you would want to load in any attributes that you're hoping to read from the PyPoint. This isn't your only chance to do it. You can do it later on, but it's certainly a nice friendly option here, just in one easy round trip. But again, since we're only dealing with tag data here and not really the configuration of the Pi tag, we're not going to feed in any attribute names to load. Now I'm going to rename this result and give it the right data type. Find PyPoints returns a list of PyPoint objects. So there we've got it, our points list. So if we really wanted to be friendly, what we could do is write out to the console that we found some tags. Let's test this. And I'll even put in a breakpoint right there just so that we can peek at what points actually made it in the list. So debug, and we're being asked what tag mask to use. Well, let's try one like what we already have, sin star. Now if I advance just past my breakpoint here, then theoretically, the system should tell us that it found 3 tags. Cool. What are they? Well, we found sinusoid, which I expected because it's one of the built-in random tags, and sinusoid U. And then, I'm not working on a pristine system here. I apparently built some tag called sinusoid is good, so we found that too. But in any case, that means that our search is working exactly as intended. The user puts in a mask to search by, and now we're finding all those points. Great. So, step 2 is going to be coming back and using those pi points. Get some data from them, and do that on a repeated basis using a data pipe.